Good evening, everybody. So now, two webinars which we took. One was the introduction to CNC. The second one was basically about the G code and M code. Right now, here, what I'm going to discuss today. Today, we are going to learn about a topic which many people feels like it's a fear for many persons. So today I'm going to some of students my students told so offsets are difficult, this that. So today we are going to see what are offsets and what is the thing in offsets, what are types of offsets, all those things. Now, whose is this section for? Who will be benefited by this session? This will be good for the freshers or the first time learners or for the CNC operators and trainees. Anyone who is confused about z-axis, offsets, and anyone afraid about the z-axis, these are the people who will be benefited by this webinar. And don't worry, I'll be starting with absolute basics. If you don't know anything, don't worry about that. Now, CNC machine. You know what's a CNC machine, right? So the machine is very powerful, very fast, and very obedient. Am I right? So it's very whichever CNC machine it is, it will be very powerful, very fast, and very obedient also. But we have one issue. Even though it's very powerful, very fast, and very obedient, we have one issue. What is the main issue? That the machine does not know where the job is. Okay, it should know it doesn't know where the job is, or where the tool tip is, or what we are thinking. The operator, the machine doesn't have brain of its own, right? It just follows only instructions. It only follows its instructions. So in that case, it never thinks on its own. So we have to tell it where the job is, where the work is, where the tip of the tool is, the end of the tool is, and what has to be done. All these instructions has to be given to the machine. Now, just imagine the situation. Imagine the situation where a person, okay, a boy or a girl, we are just blindfolding him or her, okay. We are blindfolding the person, and we are giving him a knife, okay, and we are told him to cut a cake. We are telling him to cut a cake. Does a blindfolded person, does he know where the cake is? Where the cake is? What will happen if he doesn't know where the cake is and everything? Nothing. He may just cut in the air. The item will be down somewhere, or he may be cutting in the air somewhere, or he may cut the table. He may cause some other injuries. All those things happen, right? So CNC machine basically works exactly like this blindfolded machine. We give him a work, it don't know where to cut, where to work. Understand? So sometimes those who worked in the machine, they might have noted the program will be correct. Still, the program will be exact. The machine runs on programs. So what's happening? The program will be correct. Still, the tool crashes or the wrong cutting happens. Why this happens? Why is this issue? The reason is the machine doesn't know reality. The machine doesn't know where to start, where to go, where to all those things. The machine doesn't know. So this is where today's hero, the hero of this topic, that is the offsets, come into reality. Now, the most important step, most important sentence is offset is an information. It is an information we give to the machine about reality. Okay, we give to the information which we give to the machine about the work or the job which has to be done. Next, offset. It's not a correction, a trick, or a shortcut, but it is actually telling the truth to the machine. We are telling the machine where you have to go, where you have to come, where is the job kept. That is the thing what meant by offset. Offset is also, we also tell that offset is a starting point. Every machine needs to know where to start. Okay, every machine needs to know where to start, where is the starting point. This is told by this offsets. Okay, for example, what is it? When we start reading a book, we'll have the starting point to the end point, right? We go from start to the end. Similarly, in the machine also we have to tell the machine this is the starting point. Okay, so that is where if you start at the wrong place, the complete program will go left. So that is why we are giving the importance of offset. And what is the main thing? What is the starting point? Because to know where to begin the cutting. Because we will be giving exact x coordinates, y coordinates, z coordinates, right? So, but for that, for giving the dimensions of the length or everything, we need to know where it is has to start. Because some pieces, if you say for this, for example, if you take this piece, sometimes the starting point of this will be in the side. For some places, it will be in the center. So this is how we get the offsets. The machine gets confused whether if you don't feed that, what will happen? How will machine know that my job is here? My job has to start from here, or my job measuring has to start from here. This we cannot do. So that is the main reason why we need the offsets. Now, what information does the machine need? As I told, it needs to know where is the job and where is the tooltip. Already when I told last class in the G code some code, I had mentioned about G43. Now, if this is my tool, for example, if this is my tool, each tool will have different length. Some tools will be 60 mm long, some tools will be 100 mm long, all those things. So what we have to know if this is the top surface. We have to tell the machine that this position, if the tool is in this position, it will touch the job. So that is known as where is the job tip. Now, so CNC is not that complicated. Just think these two things we have to give, main thing. Then the program. Then machine. Now coming to the home. Machine has its own home. Okay. What is it? Machine offset we call it. It is fixed. It will be fixed per point. Whereas works point will be changing. The machine coordinates, or which we called as last time I told G53, it is in it has a home which is set by the manufacturer, which is fixed and which never changes. It's like a machine starting point. Then what is this machine zero? Machine zero is we use it for safety, we use it for reference, and for the machine movement. Okay, we don't make any drawings from this machine zero. Then why we can't use the machine zero? If machine has a zero, we can use that now? No, because machine zero is always fixed and it is related to the machine's bed. What happens here? When we do a job, the job changes. Maybe it can be square, it can be round, it can be anything. So, and the fixture means which we use to hold the piece, that also changes. Then height, the job height also will change. So this is that is why we can never use machine zero. Understood? Now, what I have to do? Next thing. So we have to, for the job, we will have to use we can use our own zero. So we need to create a job zero which is meaningful to us and which is based on the drawing. Like last time when I showed you a drawing, there was a center point. All the dimensions are taken from the center. Or sometimes we will take it from the side also, right? So based on this is the If we use the machine 0, what will happen? The program will be entirely wrong. See, this is our machine bed. If this is our machine bed, and this is our job. Okay, for example, this is our job. This job can be here, anywhere, here or here or here or here or here, or, right? The machine 0 will be in this point, in this fixed point. So for a work which is here, we cannot use this point, right? That's why we use the job 0 for the workpiece or the work 0. Now there is a bridge, there is a distance between the machine 0 and the job 0, which is from the machine 0 and the job 0. This distance will be cleared by the a bridge, and that is known as the work offset. That is known as the work offset. What is the work offset? Work offset is nothing but we are defining the machine where the work is, or where the center of the work is, where the starting point of the work is. That is known as the work offset. Now, so we are discussing about two zeros. Two zeros mean what are zeros? First is the machine 0, which is the machine's home, and work 0 or the work offset, which is the jobs. Never get confused. Machine 0, which we normally give in G54, G53, that will be always fixed. There will not be change in that, and that is the machine's home. And work offset will be in G55, which will be given in the G54, 55, 56, 57, 58, 59. Multiple numbers are there. Work offsets we can give in multiple G codes. Why we give? Because if in a plate, sometimes in some companies, one CNC machine will be there, multiple jobs will be there. One piece will be regularly running product, and immediately in between we get a new work to be done. So what we will do? We will put the regularly running job in G54, and when we load the second piece, we will be loading it in G55. So what will happen? This G54 stays same. It won't be affected. We are giving it temporarily a new G code. That is the work offset. Now, so see, one piece is clamped, work is clamped. Okay, we should know whether the job is left side, right side, front, back, high, low. All these things will be told by this work offsets. Now, drawing. What's the difference between drawing and reality? In the drawing, the drawing normally shows X0, Y0, Z0, all those things, but the machine can see what? Only a metal on the table. So we have to say, without mentioning the offsets, we cannot say that offset that this is the 0, this is the X0, Y0. So to take that values, we have to give the offsets there. So this job position information is called the work offset. As we told, this job position information is called work offset. Now, why is this important? Why is it very important? Because, and why it changes? This job position changes or the work offset changes because the size of the job may change. Sometimes we'll use a big block, sometimes we'll use a small block. Then the fixture height, maybe we are clamping it on the table, or we may clamp it on a vise or any other method. So what will happen there? The height also changes, and the clamping position also changes. Sometimes we will clamp it in the sides, sometimes we will clamp it to the top. All those things has to be taken care. Okay. Now about the tool. Till now we looked about the work and the job. Now we are going to go to tool. Does every tool have the same length? No. Every tool doesn't have the same length. What will happen? As I told earlier, some tools will be 50 mm length, some will be 60 mm length, some may be very small, some may be extra long like 100 mm, 75 mm. All those things will be there. So there we will. So that is the reason why we have to give the tool height also. Machine, what machine thinks first? Okay, all tools are the same length. Does machine have a thinking capability? No, machine doesn't have thinking ability. And if the machine assumes that all the tools are the same length, it will cause a great danger. It will cause a great danger. So that is the reason we have to give the tooltip information, or this tooltip information is also called as tool length offset. It's called as tool length offset. Last time in the G-code class, G-code M-code class, I had mentioned it, G43. That is the G-code we use for setting the tool length offset. Okay. So what we will tell in this tool length offset? So this is my base. For example, this is my base. I will tell the cutter that, okay, here, if it reaches this area, that is the 0. That will be the end of the tool. So then from there we will tell it, that will be the 0. Then we will tell if it's kept on the top of the, we will give -1, -2, -3, -4. Or if it is in the base, we will tell +1, +2, +3. All those things will be taken care of. If the 0 is set in the bottom and the thickness is 20 mm, what we will say? First we will tell, okay, clear the 20 mm first. Then go down to 19 mm, remove another 1 mm. So giving this 20 mm, machine should know now, if the cutter reaches this portion, this is the 20 mm. That is where the tool length offset gets most important. Now, tools. Tool also varies. Like, remember, we use a pencil. Normally when we use a pencil, what will happen? The pencil, once it sharpens, or when we keep on writing, it gets damaged, right? It becomes shorter. It gets shorter. Similarly, what about to the tools? These tools, maybe if it is carbide or be it HSS, whatever, it is continuously touching with the job, steel job or whatever material it is. So what will happen? It will reduce its size. It will have a wear. This wear will be not detectable, but it is not negligible. How much it will be there? It will be some O1 mm or O2 mm. O2 means 20 microns, 10 microns. So these things, these also, what will happen? By taking time, this will reduce, it will change the final dimension of the piece. What will happen? We will just will get a dimension which is more than required. For example, if the dimension required is 15.00, we may get 15.02 or something. So this is known as, this doesn't make the tool bad. This is known as the wear. So normally what people do, we'll just change the tool. But what we can do, we can do a small adjustment. We can give a wear offset also. What is wear offset? A wear offset is nothing but it is we are giving that this tool has been reduced by this much. So while the work also, it has to be automatically adjusted. So what will happen by using the wear offsets? You can get the size control. You'll get a finish will be controlled, and production will be stable. This is why we also have to always check the wear offset. Now, so why normally machines crash? So machine gets breakdown or machine gets crashed. Why? Because the machine may not be bad. It is because it is we are providing the wrong information, or some information which we provided are missing, or some information is just assumed. There is not reality. It just thinks about it. That is the reason why most of the machines crash. Because machine only does what we do. Well, isn't it? Machine only does what we tell it to do. So if we tell it wrong, the machine also will do it wrong. Now, so always before pressing the cycle start is nothing but start of the work. What we have to do? First, we have to think in ourselves. We should say, does the machine know the job position? whether it knows the job position. Then does it know the tooltip position? All these things has to be first made clear. Else what will happen if my piece is 20 mm and I have not set the thing, it will automatically go, either it will cut in the air, which is safe, okay, no problem. But it may, there are also chances that it may go more down. Instead of just cutting 1 mm, it may cut almost 3 mm or 4 mm or more, and it will damage the tool and the job. Similarly, if we don't touch the machine job position, it will cut somewhere else. So how we will take the center normally? We take the center by, we have the probes for that, or else we can use the with the dial in the kept piece. We'll be touching this side, we'll be touching this side, we'll touch the 4 sides and take the center of the x-axis and y-axis, and for the z-axis we will use the cutter tip. So x and y-axis will be taken in the job and z-axis will be taken in the cutter. Now what to do when we will do the first cut? With the first cut, what is the first cut of the machine? Whenever it should be there, the first piece when you are doing, you should be very slow, very careful, and watch closely. What we will do normally, the cutter comes 0, G00, it comes to center. Then it will come very fast, right? Instead, what we have to do, we have to give the rapid very slow, and once it touches and moves a little, we have to be always with the machine, carefully looking at the product and seeing if there is any sound difference. Because if the depth is more or any mistake in the cutter or any issues, this can save us from damages. If you are getting, okay, my cutter has come with this much a height, so I pause there, I check the monitor, it says the cutter is at 50 mm, so we'll check we'll compare the height approximately. Okay, the cutter is exactly 50 mm above the piece, okay, it is correct, we can stop, we can continue the work still, and it will, once it touches, it should be always gone very slowly, it should go very slow. We have to always look for the any sound difference, or any sound difference has to be checked. So if you say the offsets means, what is the work offset? Work offset means where is the job. Tool offset means where is the tool tip, and wear offset means the small corrections which we give to correct the size changes in the tool. That is the wear offset. So these are 3 offsets main we have discussed. One is the work offset, one is the tool offset, and one is the wear offset. So what happens? Offsets, it doesn't control the machine, they control the understandings. Okay. Now, if anyone has any doubt, please ask in the comments right now. Let me see if any doubts are there. So I told you we have this G54, 55, 56, 57, 58, 59. Where we use it? I told you. Now, in some of the works, what we will do, we will have a 5-6 pieces kept in a machine. 5-6 pieces which are kept in a machine. So what we will do, we will assign each center, each job a work offset. One will be in G54, one will be in G55, one will be in G56, one in G57, one in G58, and one in the G59. And we have other codes also. If you want more coordinate, we can use the more coordinates also. So what will happen there? When we do that, we can easily switch from one job to another without removing the workpiece, because when we load a piece in the machine, when we load a job in the machine and then remove it, then again reloading it will take time, it will take energy, all those things has to be done. What will happen in this case? We don't waste the time again, because we know this. If this work has to be done again, now we're temporarily doing another work, but this old work has to be done. We don't want to waste the time in setting it again. What we will do? We'll just set all this in different work offsets, and then we will do take the offsets. Now I told you center how we'll take. We will basically take normally with we have probe for that. We will touch this side and we'll touch the y-axis, both sides. So what will happen? It comes to the center of the piece. Then we will touch the x-axis, both x-axes, and then it will come to the center again. Thereby we will get the both x-axis center and y-axis center, which will give you the exact center of the work. Another way to get this center, we will take the dial. We will take a dial. We will touch this point. We will take the high point, then make it to 0. Similarly, do it in all the 4 sides, and in that will be more accurate. And in some cases, we are doing from the raw material. What we can do? We can simply just take a cutter, turn on the spindle, slowly come, touch this corner, give the input, touch this corner on this side, give the input, touch this side, give the input, and this side, give the input. That is the way we take the work offsets of each piece. Now, what will happen for the machine 0? That is never going to change. That will be always in a fixed value. Then, what about the tool wear? Tool wear also we have to check by using the dial gauge. We will use a puppet dial and we will take the tool wear, and this tool wear will be entered into the machine. That is known as tool wear. Any other doubts? Any other doubts? If any doubt, please put in the comment box. I'll be here for another 5 minutes. Okay then. Thank you. Thank you for the time. Let's come next week with a new topic. Thank you so much.